why we needed to go further in chapter 5. Okay? So rather than waste our time with a whole chapter of chapter 4, we're just doing section 4.6, and we're doing it right now. Okay? So, complex numbers. Okay? We have complex numbers are of the form a plus bi, where a here is the real part and bi is the imaginary part. So a complex number looks like 3 plus 2i. Okay? I can write a real number like 6 in complex form, okay, by going 6 plus 0i. These two right here are the same. One's just written in its normal form, the other one's written as a complex number. It doesn't have an imaginary part, it's real. You know what it is. It's right in between 5 and 7. Okay? An imaginary number would be like 2i. Written in complex form, it's 0 plus 2i. Okay? So there's different facets of it. But all of them are based off of 2, well really it's 1, but we'll call it 2 core principles. Okay? The bedrocks, if you will, the foundation principle here in complex numbers is that I squared is equal to negative 1. Which means then, that secondary one, which means then that just I is equal to the square root of negative 1. Okay? That's our bedrock principle. Okay? Farther? Okay, good. Alright? We discovered that last year in Algebra 2. Okay, we're going to continue it on now here in Algebra Thrice. Okay? Alright? Now, we can do different stuff. For instance, we can simplify using I. Now, a couple of things with I. Non-negotiable. It's got to be written in like script type writing or with that little curly Q thing at the end. Okay? So when I'm writing I have to write it like that, or I've got to write it in cursive. Okay? Anybody know why? Because it could look like the old number 1. Okay? All right? So we got to write out I. We don't just print out I, we've got to write it out. Okay? So that we don't get it confused with the number 1. It's special in our brains. Okay? Now, again, many different ways to simplify radicals. Okay? The way I do it is I would take this and I would make this become the square root of negative 1 times the square root of 49. Okay? I'm multiplying them. Negative 1 times 49 is negative 49. So that works out for me. Okay? And then I know that the square root of negative 1 is I. And I know that the square root of 49 is 7. So my answer here for this one is 7i. Okay? Here, I would write this as 2 times the square root of negative 1 times the square root of 32. And now, what perfect square factors are there inside of 32? 8 and 4. 8 and 4, okay. So I could make the square root of 4, right? Are there any perfect square factors of 8? 4 and 2. So this would be really like the square root of 4 times the square root of 2 times the square root of 4, right? Times the square root of -1, then times 2. Okay? So 2 is 2. The square root of -1 is I. The square root of 4 is 2. The square root of 2 is the square root of 2. And the square root of 4 is 2. So 2 times 2 times 2 is 8 I times the square root of 2. Alternative way of doing that one, 2 times the square root of 1 times the square root of 16 times the square root of 2, because 16 is a perfect square that goes into 32. So then this would be 2, this would be I, this would be 4, this would be the square root of 2. Still gets me down to that. Okay? Where we're going with this is we are going to be solving equations with it. Okay? Solving equations with it. Alright? So, how would you go about solving that equation right there? One way would be get it equal to 0. Okay? Or because there's no linear term, we could do what? Not so much factor, but we could get all the variables on one side and all the numbers on the other, right? Okay. So I'm going to add 9x squared. I'm going to subtract 7 all at the same time. Okay? So that gives me 12x squared equals -3. Now what? Divide both sides by 12. That gives me x squared here equals -1/4. Now what? Square root both sides. Whenever I'm taking the square root and I'm solving, which is different than what we were doing here on this slide. On this slide, we were just evaluating, simplifying, if you will. So I'm only taking the principal root here. But when I'm solving the equations, what do I have to remember? And I take a square root. I have to remember the plus or minus. Okay? So we get x equals plus or minus. Square root of a fraction is going to be the square root of the top over the square root of the bottom. Okay? What's the square root of -1? I. What's the square root of 4? 2. So my answer here is x equals plus or minus I divided by 2. Okay? Solve that quadratic equation, please. For those of you watching on screencast, pause it. We'll be right back. Okay, and we're back. So solving this quadratic equation, first off I would subtract 6 from both sides. That would give me x squared here equals negative 6. I would square root both sides then. That would give me x here equals plus or minus I times the square root of 6. Okay? Ben?
Where do you get I times the root of 6?
Because it's the square root of negative 6 there. So if I break this out, if I go the square root of negative 6, okay, then that's going to be the square root of negative 1 times the square root of 6. So that's I times the square root of 6. And 6, like earlier today, they wanted to break that down into the square root of 2 times the square root of 3. Which is great, but neither 2 nor 3 are perfect squares, so that doesn't do me any good. Okay? Alright? So that's where we got that from.
So are you saying that if you break it down, if the two factors don't make up the square,
Then, yep, combine them right back. Yep.
So for the equation with x squared minus 6, what would your answer? What would your answer?
Then it would just be plus or minus the square root of 6.
Okay, so you want to do that.
Nope, because now you're not taking the square root of a negative. Okay? Alright? So, now, from this week, and from last week, and from the rest of chapter 5, what does having that as an answer here, what does that really mean? Means what? There's imaginary what? There's imaginary zeros, right? What are the zeros? They're, what are the other words for them? They're zeros, they're roots, they're solutions, they're answers, right? Okay? If I change forms of those zeros, roots, solutions, answers, what do they become? What's another word for them that we've been using? Say they're, somebody just said it. Factors. Okay? They're factors, right? If I rewrite them, I could write them as factors. What's the other thing that we've been talking about with them? They're the roots, solutions, answers, zeros. They're factors, and they're what? They're what kind of intercepts? They're the x-intercepts. So, maybe, there it is. What happens when I graph this function? First off, what kind of a function is it? It's a quadratic, which means that's a, say it loud, it's a parabola. Okay? Alright? So what is special about this particular parabola?
Don't you get like a hole or something?
Nope. It's actually its normal size. Yep. But, nope. That would have to be a power of bigger than 2. If I were to graph this function, what shape is a parabola? It's a U, right? Is this parabola going to look like a U, or is it going to look like a hump? You sure? Doesn't it have a positive A value?
Yeah.
So it's going to look like a U, and where's it going to cross the x-axis? What are the x-intercepts? Why? Because they're imaginary, right? So this one is going to be a parabola that doesn't cross which is why we have to give imaginary, fake, imaginary. What other words can you use for it? Made up. Okay? We're making up an answer to make sure that x squared plus 6 has something for an answer. Okay? That's why they're imaginary. It doesn't cross. It has no real roots. Okay? So, I'm going to give you some time here now to solve that one. I want you to find all the zeros to the polynomial functions. Again, on the screencast, pause it, and then jump right back into it after you solve it. All right, we're back. What do we do first? Everybody did it. I was walking around and I was looking. Everybody did it. What do we do first? Find the factors of 24. What are the factors of 24? 1, 2, 3, 4, 6, 8, 12, 24. Then what? Factors of 2. What are the factors of 2?
1 and 2.
1 and 2. Okay? So my list is 1, 2, 3, 4, 6, 8, 12, 24, 1 half. 2 divided by 2, we already got 1. 3 halves. 4 divided by 2 is 2, we got it. 6 divided by 2 is 3, we got it. 8 divided by 2 is 4, we got it. 12 divided by 2 is 6, we got it. 24 divided by 2 is 12, we got it. So that's our list, right? Okay? From that list, did anybody find one? What do you got? Positive 4, okay? What's one way we can narrow it down? Graphing calculator, okay? Or we just try some. But here then, we had positive 4 was a possibility. Okay? You can't see it, but this really is my function. Okay? All right? So let's try here now positive 4. 2, negative 9, 10, and negative 24. 2, 8, negative 1, negative 4, 6, 24, 0. Bingo. Okay? So 4 is a 0, which means what? What's a factor? X minus 4 is the factor. Okay? So we can rewrite here now f of x as x minus 4 times what? 2x squared minus x plus 6. And does 2x squared minus x plus 6 factor? Nope. Okay, otherwise, we would be doing a problem like yesterday. Okay, so that's going to be x equals 4. That's the one we found. 2x squared minus x plus 6 equals 0. So if it doesn't factor, what do we have to use? The quadratic formula is what we have to use. So we go back to x equals opposite of b plus or minus the square root. B squared minus 4ac all over 2a. Okay? So that's going to be positive 1 plus or minus the square root of negative 1 squared minus 4 times 2 times 6 all over 2 times 2. So that is going to be 1 plus or minus the square root of 1 minus 48 all over 4. 1 minus 48 is negative 47. But do I like that? No. So that becomes 1 plus or minus I times the square root of 47, because 47 is prime, it doesn't have any factors. Okay. So all of my zeros here then are 4 and 1 plus or minus I times the square root of 47 all over 4. Okay? So we can find all of our zeros. And so how many total zeros do we have? 3. We got 1 at 4. Okay, we got 1 at 4, and we've got 2 of them in there. 1 at 1 plus I, 1 at 1 minus I times the square root of 47. Which if I go back to my problem, because that's a 3 right there, that makes it, I need 3 zeros. Okay, fundamental theorem of algebra. Okay. Your homework tonight is section 4.6, page 279, 3 to 11 odds. It will be due on Friday, which is tomorrow, which is the 4th of November. Okay? Last class they finished it all